Hi everyone, my name is Jean-Christophe. In this beginner Python tutorial, we will learn about Python lists. In Python, lists are one of the four data types that are used to store collections of data. That is, multiple items in a single variable. The four data types that store collections are dictionaries, lists, sets, and tuples, which we'll cover in other lessons. Lists are created using the square brackets. So let's make an example to show what lists are. First, we create a variable equal, and then we use the square brackets and add the value within the list. If we show the list, then we'll see the result is a list with the square brackets. If you use type method, we can see that this is indeed a list. Then we can start storing various kind of items, such as strings. So you use the square brackets notation, Python, SEO, and as we'll see by referencing it, if we show what the variable is we have a list. And it can reference other things like booleans, such as false and true. So this also works. You can store various data types. Another cool thing is to do nested lists. So we can store lists within lists, such as 1, 2, 3, and 4, 5, 6 just here. So we have nested lists within lists. If we want to reference, we'll see indexing a bit later, but if you want to take the first list from the list, then you can select it using the index. So I'm showing the first element of the list is the other list. If I want to select another item within the second list, then I can reuse the square brackets, such as what we just see. We can also change stuff to nest more and more lists within lists. So there are no real maximum level of depth for lists. Here, if I create a new list, I can reference it by creating a new depth and using the square brackets again. We can store other things such as tuples. So ls equal, and then I use the same square brackets. Use dictionaries, so we can say ls equal this, and I create my dictionary A, column 1, B, column 2. So each item is a dictionary. So if I say type ls, this is a list, but if I say type 0, then it will return a dictionary. So each item is a dictionary within the list. So lists are very flexible. You can use multiple data items such as hello, one, false, etc. and a nested list, for instance, 0, 1. So there are no kind of limits to what you can do. However, the limit that you'll face here is if you try to sort that list or do kind of things like this, you won't be able, because it will throw a type error because you're trying to sort various data types. So you need to be aware of this when creating your list. Now let's talk about indexing lists. If you want to get the first element of the list, then you need to reference the variable and use the square brackets notation. Let's create a new list, and if we want to get the first element, then we would use ls square 0. This is called zero indexing, which is Python way of starting of counting from 0 instead of 1. So it's on that list we would count 0, 1, 2. If you want to get the last element of a list, then you need to use the same variable square brackets notation. ls square, and then instead of the 0, we use -1, which tells you this is the last variable of the last value of the list. If we want to select more than one value, then we will need to use list ranges. Now we have a lot of values. reference a variable, use the square brackets, and then we start from the first index we want to include. So it's 0, 1. Then using the column, we will initiate the range. So we start from index 1, column, and the last index we want. But the last index will not be included. So here is 1, 2. So as we see, we're not selecting from 1 to 3, but we're selecting from 1 to 3 excluded. So this is how ranges work with list slicing. If you want to select a list from the start, let's copy back that list again. And if you want to get a list from the start, all you do is column 3. Then you select from 0, 1, 2. You can also select a list from the end, but instead you start with the index you want to include, and then you use column, and that will be implied that you want to select everything from index 3 to the end of the list. Now let's talk about modifying lists. Let's recopy that list again and try to change a single value. So here we can select the index just as what we did, but instead of just showing it, we can use the equal sign and add a new value. As you can see, it doesn't have to be of the same data type. So here we can see the new value is added to index 1. If you want to change multiple value, then what you need to do is again use the list range and use equal sign and add the list of values. So here I can add a string, I can add a boolean. It doesn't have to be the same data type again. So if we show the variable right now, we'll see that the indexes were changed with the new values. If you end up adding more values than what you've selected with the index, what will happen here? Let's add another example. So here I have 3 values, and I want to add multiple value to the end of the list. So here I'm showing what I mean. So I'm essentially want to change the last value of the list. And if we look at this, this is a length 1. So what if we want to add more than one value to this? What will happen? So if I add a list with 3 values inside and I reference it, what will happen is that it will add the first of what you've selected, and everything that is longer will be added to the end of the list. So this is a good segue into the next topic, which is adding items to the list. If we have an empty list, we can initiate an empty list by saying ls and putting nothing within the square brackets. Then we can use the append method and add whatever we want there. So if we look, so one thing is interesting here is you don't have to do ls reassignments such as like this. What you just need to ls append and it will be added straight within the list. It's automatically done this way. This brings me to one of the pitfalls of using the append method. What if you want to combine those two lists within a single one? If you could think that you should do ls append and you could append a second list. What will happen if you do this? What would happen if you append the list 2 to the first list? It will, at the end of the list, add the new list. So now you end up with a nested list, which is not what we wanted at first. This is where it brings us to the extend method. So instead of using append, we can use extend ls2. And if we look at the new list, then it does what we wanted to do initially. For the last item of adding values, we will use the insert element. So if we want to insert a value within our list, so now we have 1, 3, 4, we want to add 2 at the index 1. We want to add 2 here where it's missing. So we can use the insert method, and we can say in index 1, add the value 2. Then if we look at the list, we can say that, okay, 0, 1, it wasn't 2, 3, so the value 2 was added to the index 1. Next, if you want to go the opposite way and remove items, you can use the ls remove method by saying you want to remove the letter A from that list. Then if you return that list, you've removed it. Another thing you can do is you can use pop. If instead of using remove, you want to remove pop using the index instead of the value. So right here what we did is we removed the value. But if we want to remove using the index, for instance, 0. So if we just use pop, empty like this, what it would do is it will automatically remove the last value. If alternatively you want to remove the first value, you could use the index. And now we've just removed the letter A. One other way to remove item is to use the delete keywords. So you go here and you do del ls and you remove the index you want, and then you look at your list and it is deleted the way you want it. And last way to remove item from a list is to use the clear method, and what this will do is it will clear the entire list. Now you're returning an empty list. Now, creating lists. So we saw one way of creating a list, which was using the square brackets and doing 1, 2. Let's look at another way is to use the constructor. So if, for instance, you start with a tuple, which is 1, 2, 3. We have a tutorial on what tuples are, but for instance, one of the things that a tuple is compared to a list is that you cannot reassign a value to a tuple. Otherwise, it will return an error. If you want to convert the tuple into a list, you can just do list t, and then you get your list. And then if you reassign this to a new variable, what you could do is you could say list 0 equal 25, and then you look at your list and it was properly modified. What did I do here? What happened here? Let's start over. We had a tuple, we created a list. Here we have our list. If we change, well, oh, okay, because I was using a list. Okay, here if we call the list, we get the 25 that has been changed. Sorry for that mix up. Next, we can create a list using a list comprehension. So first, if you've never heard about loops, let's do a quick introduction, very quick, but I have a tutorial on Python loops which you can follow next if you want. But a loop is, for instance, I could say for I in range 10, so for instance, what it says is for each number in a range of value from 0 to 10, so if we say range 10, range 10 is 0 to 5. So if you want to say for each number in range 10, you could say print I, and what it will do is it will create your list. It will print each element. If you want to add items to the list, you could say for I in range 10, you could say ls append I. And then instead what it will do is you would print your return list, and you would have created a new list using a for loop. So this is not a list comprehension. This is creating a list with a for loop. An alternative way to do that kind of for loop in a more succinct way is again using that for I in range 10 logic. So now instead you start with brackets, and then inside the brackets you say I for I in range 10. So it would do the same kind of lookup of what it says, but for I in range 10, add a new I. So what it does, this is your list. This is a real list comprehension. It's a lot more succinct. It's a bit confusing at first, but once you get the hang out of it, it makes your code much cleaner. Now we've seen this. What if we want to loop through a list? So essentially, using lists, one of the powerful things you can do with a list is looping through it. So we kind of seen what it is. For now, what I say is I could loop. So I have that list of 5 items, 5 string items. I could say for each element in the list, then I use a column. I could say print the element. And now this would have printed the element. Next, you might want to loop using the index. There are many reasons why you would want to do this. But if we have this index, we can see that we have within that list, we have a length of 5 items. And if we do range 5, then we get values from 0 to 5. So we can use that range length into a loop. So we could say for I in range length list, I would say print I. So what it would say, it would return the index each time. But instead, we could also decide to get the variable instead. So when you learn how to do loop, it's good to use print statement to try to understand what's going on. But now for each integer, each index within the range length of my list, then select the integer. So here you could see that at integer 0, the item is named Python. At integer 2, the item is named machine learning, etc. And this could be useful in order to, for instance, create a dictionary. So I could say I could start with an empty dictionary, and I could say, okay, D equals at index Y, add the ls equal y, and then if I return my dictionary, then I could say that, okay, I just created simply a dictionary using loop. If I would have just used the select each element such as we did right here, then I wouldn't have had the integer, and I couldn't have possibly created that dictionary. So this is one of the use of using the index instead. So bear with me. I know that while I know that range length can be unintuitive when we start, but over time you'll get a hang of it. Practice a lot your loops and you'll understand it better. There's an alternative loop that you can use, a while loop, which is you can start with an integer, and you would how a while loop is do something until the condition is met. So you could say while true, print hello. So if you run this, there are no conditions, so you end up with an unlimited. It will infinite loop. It will never stop looping until your computer program crashes. So what you can do instead is using a while loop. You can just create some rules. So you could say while I is smaller than the size of your list, then you could say, instead of print hello, you could say print I ls I. So then if you don't put any condition, then you will still have that infinite loop. So what you can do is you would say I plus equal 1. So what it would do is it would go through your list, it would start from 0, it would print your index 0 within that list, then it will add 1 to the initial number, it will become 1, then so it will print the index 1 and the list item 1. And then it would do so on until it reaches the end of the list. So now when we run that while loop, we can see that it properly worked and stopped when it reached the end. When I became equal to the length of the size, and it stopped. So we've seen list comprehension. We can do similar. So we can say print element for lm in ls. Then it will print each item. This is what I told it to do, and then it would return an empty list here. Okay, so that was a lot. Looping is a bit more complex. Let's see powerful stuff we can do. Here we could say, let's look at that initial list. I created a list using a list comprehension. I could search for that list. If I want to know if the number 5 is within the list, I could say if 5 in a list, then I say print found. Then okay, it's found. So I could use this to search within that list. I could do other things such as sorting a list. So again, list sort and then return ls. So then we will have those sorted. And remember, if the various data types are a bit different, then you would end up with a type error again. So be conscious of that. If you want to sort that as multiple duplicate value within your list, because list allows you to add duplicate value, then it will be sorted accordingly. You could do a reverse sort by saying ls sort reverse equals true. Then so if you just do like this, it returns nothing. You need to ask for it to be returned, and then it's reverse sorted. You can join a list in many ways. One of the ways is you take that first list and you add it to the second list. So then this is similar, but it's different to the extend method that we, what happened, list 1 and list 2. So we see that it's been combined properly. It is similar, but it's a bit different to ls1 extend. Because if we say extend, because if we let's take ls1 right now, it hasn't been changed. I just summed them together in order to so if we use the extend method and extend ls2, this is equivalent to saying ls1 equal ls1 plus ls2. So the extend automatically changed, reassigned to the initial variable. So earlier when I summed them together, the list didn't got reassigned to the variable. The variable stayed the same, but by using extend, the variable completely changed. So this was the tutorial, the end of the tutorial on Python list. Please help me and subscribe to this channel. If you enjoyed this tutorial mentioned, you can ask any question in the comment. So stay tuned for my upcoming Python SEO course. I will share it within the comment of this article when the course is out there. So thank you very much and have a good day.